Good day to you out there. You are welcome to Science Explained. This is the second episode on the topic trigonometry. If you had watched my first episode on trigonometry, you will notice that this was exactly where I stopped. So I am continuing from where episode 1 stopped. What I'm starting with today on this episode is how to convert angles in degrees to radians. Like I told you, in calculus we use radians. So, number 1, you need to know that 180 degrees is equivalent to pi radian. So if I want to know what 1 degree will be in radian, I will just divide both sides by 180. And 1 degree will give me this, pi over 180 radian. So since this is a unit degree, it means that you can use this one to multiply any angle given in degree. Whatever you get will be in radian, as we are going to see now. So if you take note of this, using this to multiply any given angle in degree, we take that angle to radian. So for example, I'm going to pick some angles which I will in degree that I will convert to radians. Now, let us go. Convert the following. Now, I want to convert the following angles in degrees to radians. Do not forget, I gave you a hint that 1 degree is equivalent to pi over 180 radian. So if you can remember this is the conversion value that I will use to multiply each of these, and it will take me to radian straight. So if I want to get number 1, which is 60 degrees, I will just use this conversion standard to multiply this. So that will be 60 times pi over 180. 60 here 1, 60 here 3. That will give me pi over 3 radian. How I've done this? Let me do this. 45, that is, remember to go 3, I. 45 degree to radian will be 45 times pi over 180. I would advise you leave your conversion in fraction. So how many times will 45 go in 180? That is 4 times. 45 here 1, 45 here 4. That means 45 degree will be pi over 4 radian. It's as simple as that. Let me do II, which is 90 degrees. Then I will leave these two for you to try on your own and get back to me, whatever you get. 90 degrees to radian will be 90 times pi over 180. 90 will go in 180 2 times. That will give me pi over 2 radian. And that's how you convert using this conversion standard angles to radians. So try these two and let me know what you get. Okay, 270 will give you what? So I'm going to pause the video for you to try this too. Okay, let's see whether you are right or wrong. 270 to radian. 270 degree to radian. That will be 270 times pi over 180. So that will give me 0 cancel 0, 9 here 3, 9 here 2. You will notice that nothing can go here again. So that will be 3 times pi. 3 pi over what? 2 radian. That is the answer. If you are correct, you will know. As for 150 degree, that will be 150 times pi over 180 degree. 0 cancel 0. The common factor here is 3. 3 here 5. 3 here 6. That will give me 5 times pi. 5 pi over 6 radian. And that is about that. How you convert from degree to radian. And I believe that you can reverse it if you want to convert from radian to degree. Since you multiply by pi over 80 to get degree to radian, all you need to do is to divide by pi over 180 to get radian back to what? Degree. You are reversing the situation. It's as simple as that. Now, the next thing I want to talk about under this episode is the relationships between trigonometry ratios. Now, I will start by letting you know that there are angles, two angles that are called complementary angles. When two angles are complementary angles, it means if you add the two together, it will give you 90 degrees. The addition of the two complementary angles, addition of any two complementary angles equals 90 degrees. For example, let's use alpha and theta. These are mathematical symbols. Alpha and theta can be any number. But using symbols, if alpha and theta are complementary angles, it shows that the word complementary means addition of the two must be equals to 180. Okay, let me use alpha and beta. Okay. If alpha, I can use any symbol. Please don't be confused about that. If alpha and beta are complementary angles, it means that addition of alpha and beta will give me 90 degrees. Therefore, from here, we can imply that alpha is 90 degrees minus beta by moving beta to the other side. Also, beta is 90 degrees minus what? Alpha, if we are transferring or shifting alpha to the other side. Do not forget that if I want to change this degree to radian, I can do it. If you check my previous video, episode 1, I mentioned it there that 90 degrees is equivalent to pi over 2 radian. Therefore, this can also be written as this: pi over 2 minus beta. Pi over 2 minus alpha. Do not be disturbed or confused. Degree, radians. If I'm talking about degree, this is it. If it is radian, this is it. So I'm still saying the same thing, okay? Finally, on this episode, let's assume that alpha and beta are complementary angles. What does that mean? It means if you add alpha and beta together to give you 90 degrees, or if you subtract alpha from 90 degrees to give you beta, or if you subtract beta from 90 degrees to give you alpha. That is what makes the two of them complementary. Now, if we are given cos alpha can be used to get sine, and it will be the same thing as sine of 90 degrees minus alpha. That is, if you find cos alpha, cosine alpha, whatever you get for cosine alpha will be the same thing you will get if you find sine of 90 degrees minus that alpha. So that means these and these are the same. And in radian, it will be like this, pi over 2 minus, because pi over 2 radian is the same thing as 90 degrees. And the same thing applies here. Cos beta is the same thing as sine of 90 minus beta. And so on, like this. Finally, it means cos alpha equals to sine beta, and sine alpha equals to cos beta. It shows here, because by the time you subtract alpha from 90, what you get is what? Beta. That means cos alpha equals to what? Sine beta. So the whole of this is beta now. If you follow that, 90 minus alpha will give you beta. Don't forget, alpha plus beta is what? 90. Provided they are what? Complementary. Please do not forget that. If they are not complementary, this cannot work. So, I'm talking about complementary angles. I don't want you to misinterpret what I'm saying. So, as long as the two angles sum up to 90 degrees, this follows. That means here, if you subtract beta from 90, what you are getting is what? Alpha. That's why cos beta equals to what? Sine what? Alpha. Cosine beta equals to sine alpha, which is this. Cosine beta equals to sine alpha. So if you subtract this and so on and so forth. So before I round up, I want us to apply this to solve one or two problems. Then this will mark the end of episode 2. Episode 3 will continue from where we stop on this episode 2. Do not miss any of the episodes in order to have complete knowledge of trigonometry. It's getting interesting day by day. Let's have a look at these questions. We want to apply the knowledge of complementary angles to solve this problem.